Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Introduce me from my group, my spirit group, Nari Kartika. Here I will present a summary of mining engineering journals with the title Optimizing of Drilling and Blasting by Empirical Modeling, specifically CUSRAM and Modified CUSRAM model at Midrock, Durable Limestone, Quarry Site, Durable Oromia, Ethiopia. I will present the introduction section. Let's go. Here is title assignment, understanding journal article, name group, spell read, group member, Nurjana Suharyanto, Rifki Oktarino, Aurtayo Arisianipar, Nina Kartika, Ismi, Endang Sri Estari, dan Putri Abdul Sarasati. Okay, well, I will read introduction section entitled Journal Mining Engineering Optimizing of Drilling and Blasting by Empirical Modeling, specifically CUSRAM and Modified CUSRAM model at the Midrock, Derba, Limestone, Quarry Site, Derba, and Oromia, Ethiopia. Introduction. Blasting, the primary stage of rock size reduction after drilling, and it is followed by crushing and grinding action on the combination system. The main objective of blasting action in the mine is to produce a fragmented rock with sizable and cost-effective way. During blasting, the blasterman should consider the geology of the blasted rock, the cost of drilling, proper use of explosive, the size of the fragmented rock, and so on. The outcome of blasting operations is determined by a number of events or parameters, which can be either controllable or uncontrollable. The controllable parameters are basic black design parameters, which can be varied to adjust the outcome of the operation, and this product provides the accurate result. Assumption the raw mass is homogeneous and without discontinuous. However, since the uncontrollable ones are inherent properties of the rock geology structures, which are often defined by fractures distributions, need to be factored and included into the blast design. And section 2. According Howlett 1999. The controllable parameters I classified in the following groups: geometer, charge length, burden, specific, and other. Physical, chemical, or pertaining to exposure, types of explosive, strength, energy, priming, systems, and other. Time, delay timing, and intention squares were the uncontrollable factor include, but are not limited to geology of deposit, rock strength, and properties present of water joint, and other. Drilling and blasting are the critical and important operations of every hard rock mine, contribute up to 25% of the overall mining cost in some mining operation. However, optimization of the cost of the mine is mainly considered drilling and blasting. If we consider this as a part of optimizations, we can reduce the overall production cost of the mine. In order to minimize the cost of drilling and blasting, we have to model and predict the size of fragmentation. There are two broad classifications that help in modeling the fragmented rock. These are empirical modeling and a mechanistic model. Empirical modeling infers finer fragmentation from the higher energy input, while mechanistic modeling tracks the basics of detonation and the process of energy transfer in well-defined rock for specific blast layouts, driving the full range of blasting results. When compared to mechanistic modeling, empirical modeling is one the most reliable and easy to use. Thanks. Of detonation and the process of energy transfer in well-defined rock for specific blast layouts, driving the full range of blasting results. When compared to mechanistic modeling, empirical modeling is one the most reliable and easy to use.
Point 3. Result and discussion. Fragmentation prediction. The result of the prediction of fragmentation for all blades at Derby Midrock, Siemens, limestone core by Kurzram and modified Kurzram are shown in a table 7. The summarization of the fragmentation are presented in comparison form between two methods, Kurzram and modified Kurzram. Fragments from blasting with size less than 10 cm are considered as fine. The fine 70 cm prediction for all blades is shown in a table 7. Above are not considerable and not more than 1.06% by Kurzram and 0.2% and by modified Kurzram models. Almost 98.94% of the fragmentation in which the Kurzram fragmentation model results are predicted under oversize and no need of external or additional operation, and it is directly goes to the primary cruiser. And also, as we see in the modified Kurzram model, around 99.80% were predicted under oversized material. This implies that almost the blasting practice in Derby Midrock limestone quarry site were very healthy. Mean fragment size. The predicted mean fragment size for all blades as shown in table 8 below are between 16.61 and 19.76 cm for the Kurzram, and from the modified Kurzram model between 16.99 and 20.21 cm. When we compare the two fragmentation prediction model, the modified Kurzram model is still near to the actual mean fragmentation size as compared to the company data that installed from the cruiser unit.
Okay, now our presentation about conclusion and recommendation. Number one, it's conclusion. The desired size between 10 centimeter and 70 centimeter. Contain more percentage than other size and offer size. Both goes RAM and modifies goes RAM. Model gets best prediction when relates to the company prediction system that's already installed in the user unit and the display on the screen in the control unit. Point 3, modifies Kurzweil is better the fragmentation prediction model converts to Kurzweil model in the all blast state from blast A to blast F. In the all fraction of fragmentation from blast A to blast F, escape the blast A E above 99% of fragmentation did not need further treatment like secondary blasting or handling after primary blasting is complete. The average amount of fine products in thick blast is not more than 26.03% by Kurzweil and 22.02% by modifies Kurzweil method. And also in both model, in the average oversized material products is less than 1%. And what is and also in the both models, in average oversized material products is less than 1%. Therefore, the blasting practice of the company is very healthy. So next, the point is recommendation. Point 1, the company must be attention with the modified Kurzweil model for prediction of fragmentation at major thereby limited quality in the other the book best blasting practice with precise fragmentation. Point 2, since the result of the prediction from all the models at a strong correlation. Collection. They may be used designing a blast for 3 gene areas with sufficient knowledge of the raw properties, as this might be better than the trial and error method commonly used in industry. Okay, next. Okay, the next explanation will be explained by my colleague. So the last part of the summary of the article's journal presentation is the reference. Reference are searchers taken to make this article in the form of a book or other journal. There are 11 searches used. And number 1 is Jerningham GVB 2005, the Kurzweil fragmentation models to 12 years on Brecon Conference proceedings to 2005, Erhammed et al. European Federation of Explosive Engineers. And so many reference they use of article. So this is a last part, and thank you for your attention. I'm sorry if there are mistakes in words or actions. Assalamualaikum warahmatullahi wabarakatuh.